Hello everyone, my name is K. Reddy, working as Assistant Professor in Tegal Krishna Engineering College. Welcome to my channel. My channel name is Accelerate Your Research. This video, I will explain power quality and facts subject. In my previous video, I explained Introduction to Power Quality and Facts. Syllabus I explained. This is subject in JNTH R18 syllabus, 4th year, 2nd semester. This is a professional elective 5. Okay, now I will explain syllabus. This is the Professional Elective 5, Power Quality and Fact subject. This is R18, BTech JNTH EEE syllabus. This subject in 4th year, 2nd semester. This video I will explain 4th Unit 1, Power Quality Problems in Distribution System. Power Quality Problems in Distribution System subtopic. Transient and steady state variations in voltage and frequency. Next, unbalance, sag, voltage sags and spells and interruptions. 4 definitions. These 4 are power quality problems in distribution system. Next, waveform distractions. In waveform distractions have harmonics, noise, notching, DC offsets, fluctuations, flicker, and its measurement. Here, total 6 waveform distraction, harmonics, noise, notching, DC offset, and fluctuations and flickers. This total related to waveform distraction. These 4 related to unbalanced sags. These are our power quality problems in distribution system. Now I will start my presentation. Okay. Unit 1, power quality problems in distribution system. Subtopics are transients, steady state variations in voltage and frequency, transient state voltage and frequency, unbalances, sags, spells, and interruptions. Okay, these are the power quality problems. I will explain one by one. First, unbalance. This is the voltage unbalance. This is the diagram figure 1 and figure 2. Figure 1, VA and VB or VC are the three-phase voltage magnitudes. Here, this is the balanced circuit. This is the unbalanced circuit. In unbalanced circuit, VA, VB, and VC are 3 voltages are unbalanced. This is the three-phase unbalanced waveforms. This is the R phase, Y phase, and B phase. Otherwise, A phase, B phase, and C phase. 3 phases are magnitudes are not equal. This is the definition in figure 1 related. This pair are related to figure 1. This pair are related to figure 2. In balanced sinusoidal system, the 3 line neutral voltages are equal in magnitude and phase displacement from each other 120 degrees. Okay, this figure. VA and VB 120 degrees phase shift, and VB and VC 120 degrees phase shift, and VA and VC also 120 degrees phase shift. The magnitude also, the 3 VA and VB, VC magnitude are also equal. In unbalanced system, the VA and VB phase shift also difference, not in exact 120, and VB, VC, and VC and VB also not 120. The magnitude also different. This is an unbalanced system. This is the waveform. The A phase and V phase, the magnitude is comparing to A phase, this B phase and C phase magnitudes are less. Okay, this is the unbalanced system. Unbalanced system, the magnitudes also magnitudes is different. At the same time, the frequency also not the phase shift also not 120, not exactly 120. Some difference above or 120 or below 120. Okay, this is the voltage unbalance. Next, this is the under voltage and over voltage waveforms. This is under voltage. Under voltage means this is the sinusoidal input voltage. Here, this red color is the under voltage. Under voltage means the voltage drops below 90%. Okay, it below 90%. At the same time, the below 90% voltage, it maintains still more than 1 minute. That is called under voltage. This is the definition. Under voltage occurs when the RMS voltage drops below 90%. The RMS voltage drops below 90% of the nominal RMS voltage. Okay, and stays at the level for more than 1 minute. Okay, this dropped voltage, it maintains still more than 1 minute. That is only under voltage. Okay, it less than 1 minute, that is not under voltage. only it maintains dropped voltage more than 1 minute. That is all that only under voltage. Next, over voltage. Over voltage means, okay, here definition. The over voltage is an event where the RMS voltage, RMS means root mean square voltage, RMS voltage is rise above 110%. Okay. This red color is the over voltage. This over voltage rises above 110% of the nominal RMS voltage and stayed at the level for more than 1 minute. Okay, when maintaining this above 110% voltage more than 1 minute, that time only over voltage. Otherwise, under voltage and over voltage names sag and spell. Okay, sag and spell also same, but here the time is different. Here more than 1 minute only under voltage and more than 1 minute only over voltage. Next, voltage sag and voltage spells. These are the voltage sag and voltage spells. The duration time here also duration. This is y-axis is the voltage and x-axis is the time. This is sag. Sag means when the RMS voltage decreases, this RMS voltage decreases between 10 and 90%. When the voltage between 10 and 90% for the duration of half cycle to 1 minute, the time in shock voltage less than 1 minute and cycle half cycle to 1 minute only, we will consider shock. Above 1 minute call over under voltage. Here voltage spell. When the RMS voltage increases, okay, RMS voltage increases over the 110% for the duration of half cycle to 1 minute. Okay, this is half cycle to 1 minute. Above 110%, we will consider voltage spells. If more than 1 minute, we will consider over voltage. If less, if here also voltage between 10% to 90%, more than 1 minute, we will consider as under voltage. The difference is over voltage and under voltage is, the difference is over voltage, under voltage is time. Here 1 minute, here also 1 minute, more than 1 minute, here half cycle to 1 minute. Voltage sag and voltage spells. Next, interruptions. Interruptions classified into two types. Mainly, one is the short interruption. So the second one is the long interruption. The short interruption means the complete in voltage sag and spell voltage decreasing, RMS voltage dropping voltage. Here interruption means the complete power voltage will turn off. The complete loss of voltage on one or more phases for time less than 1 minute. Okay, this is very important. Voltage, one or more phases. One or more phases means single phase or three phases. Single phase or three phase, the voltage total completely turn off more less than 1 minute is called short interruption. Here long interruption, the complete loss of voltage on one or more phases. One or means single phase or three phase more than 1 minute. Okay, complete voltage turn off one or more. One or more means single phase or three phase. Total voltage will turn off more than 1 minute is called long interruption. Now, this is the power interruptions. Total we have here 4 types. The different types of power interruptions are classified according to their duration. Based on time duration, the interruptions are different. One is the momentary interruption. Second one is the temporary interruption. Third one is the sustained interruption. Okay. This is the interruption waveform. This is the voltage, 100% VIN voltage. This is the x-axis is time. This is the IEEE 1159 standard. Based on IEEE 1159 standard, we will consider this momentary, this is temporary, this sustained. Okay, first I will explain one by one. This is the first instantaneous interruption. Okay, instantaneous interruption means is a complete loss of voltage on one or more phases of conductors. One or more means single phase or three phase. The time period of interruption is 0.5 cycles to 30 cycles. Okay, here not time considering. In instantaneous interruption, we considering only cycles, 0.5 cycle, and it means half cycle to 30 cycles. Here 0 to half cycle to 30 cycles. Only we will consider half cycle to 30 cycles. We will consider instantaneous interruption. Next, second one is momentary interruption. This momentary interruption is complete loss of voltage on one or more phases, one or more conductors for the time period 30 cycles to 3 seconds. Okay. Don't consider this one here. Time, this pair of time consider. Okay. Don't consider this 0.5 cycles to, this is wrong. Okay. Momentary interruption is complete loss of voltage on one or more phases conductors for the time period is 30 cycles and 3 seconds. Okay, this momentary interruption time duration is 30 cycles to 3 seconds. Here, first one is the 0.5 cycles to 30 cycles. Next, this 30 cycles to 3 seconds is the momentary interruption. Next, this third one is the temporary interruption. Temporary interruption considering 3 seconds to 1 minute. Okay, here total this 3 instantaneous interruption, momentary interruption, temporary interruption. These 3 interruptions are related to short interruption. Short interruption means 0.5 cycles to 1 minute. Next, this sustained interruption is a complete loss of voltage, one or more phases for more than 1 minute. If more than 1 minute interruption, we will consider long interruption. That name is sustained interruption. This total related to power interruptions. Okay, 0.5 cycles to 30 cycles, 30 cycles to 3 seconds, 3 seconds to 1 minute, next to above 1 minute. Okay, this is the important, this power interruption. Next, this is the voltage reduction standards of IEEE 1159 and 1995 standard. I will explain this total, this diagram. This is the x-axis, the percentage of magnitude of the voltage, 0%, 10%, 90%, 100%, 110%. This is the time period, 0.5 cycle, next 30 cycles, next 3 seconds and 1 minute. Okay, here dips, voltage dips and voltage swell. Voltage swell means the magnitude of the voltage is more than 110%. Next, the voltage swell or dips means the voltage it maintains 10% to 90%. This is called voltage dips. Next, here short interruption. Short interruption time means 0.5 cycles to 1 minute. This is called a short time interruptions. Next, long interruption. Long interruptions means the voltage total turn off more than 1 minute. Okay, this is 0.5 cycle to 1 minute is called short time interruption. Here 1 minute and above 1 minute is called a long time interruption. Next, in short interruption, here instant and moment and temporary. In instant interruption, 0.5 cycles to 30 cycles. This is called instant interruption. Next, moment interruption, 30 cycles to 3 seconds. This is called moment interruption. Next, 3 seconds to 1 minute. This is called temporary interruption. This total related to interruptions. Okay, this is the 1 minute. This is called under voltages. This is called under voltages. This is over voltage. Under voltage means the magnitude of the voltage is 10% to 90%. More than 1 minute time duration is called under voltage. Next, over voltage means the magnitude of the voltage more than 110%. It may the time duration more than 1 minute is called over voltage. This is total voltage reduction standard, IEEE standard 1159 1995. In this diagram, total covered all voltage sag and voltage swell, over voltage, under voltage, all important points. Next, we will explain waveform destruction. Waveform destructions have mainly these 6 harmonics, noise, notching, DC offsets, and fluctuations and flicker and its measurement. Total these 6 subheadings: harmonics, noise, notching, DC offsets, fluctuations, and flicker and its measurement. First, I will explain noise. Okay, this is flicker, this is transient, this is noise. In noise, an unwanted electrical signals in power system, that is called a noise. Okay, unwanted electrical signals in power system is called a noise. This noise we observe in transformers, in transmission, near transmission lines. Okay, we'll observe this noise, unwanted electrical signals in power system. Next, notch. Notch in voltage due to rectifier action. This is the notch. Okay, this one. Here also this one. This total. This one also notch. Okay. The reason behind this notches, three-phase rectifier. Okay, three-phase rectifiers, it converts AC to DC loads. In AC to DC converting, we are using total 6 thyristors, T1, T3, T5 upper switches and T2, T4, T6 lower switches. When we are turning on A phase to D phase, B phase and B phase to C phase, or R phase to Y phase to B, when we are turning on and off switches, that time this notches will occur in AC wave. Okay. With the rectifier loads, there are commutation periods where the line-to-line voltage falls to zero. Next, this effect is due to the finite inductance in the supply. Next, this causes of finite time for current falls to zero in one phase and other phase. The main reason for this notches in voltage due to rectifier loads and in DC loads. Okay, DC motors. Next, this is the offset voltage. The presence of DC voltage or current in the AC power system is called a DC offset. This is AC sine wave. In the sine wave, input voltage is here 311. This is the maximum voltage 342. This is the DC offset period. Okay, presence of DC voltage or current. DC offset period means this the DC offset 31 volts. Fundamental voltage is 311, 50 hertz. DC offset 10% of the peak voltage. Here it maintains this small duration of time. It means constant voltage. That is called a DC offset voltage. Okay, this offset voltage definition: the presence of DC voltage or current in AC power system. This is the waveform of DC offset. Next, voltage fluctuations. Here, these are the voltage fluctuations. This is a single phase waveform. In the single phase waveform, voltage sags and voltage swells and everything have this the diagram name is voltage fluctuation. The main reason for this voltage fluctuations are welding machines and arc furnaces and heavy loads. Okay, this mining and rolling mills. The definition is voltage fluctuations can be described as repetitive or random variations. Okay, here repetitive and random variations means this waveforms random variations of the voltage envelope due to sudden changes in the real and reactive power drawn by the loads. The characteristics of voltage fluctuations depend on the load type and the size of the power system capacity. Okay, this is the fluctuations, voltage fluctuations waveform. Main reason is arc furnace and arc welding and installations with frequent motor starts, air conditions, fans. Okay, these are the reasons voltage fluctuations. Next, this is a flicker. The main reason is example tube light. When we will turn on tube light, so starting few seconds, the tube light will turn on and turn off. Okay, that instant or that moment is called a flicker. Okay, this is a flicker. This thick line. Okay, this is a flicker. Repetitive voltage reductions in lighting circuit can be detected by human eye, known as a phenomena as a flicker. Okay, this flicker we will observe in tube light. When turn on tube light, we will observe that it will flicker. Repetitive voltage reductions in lighting circuits can be detected by human eye. A phenomenon is called flicker. Some common sources of flicker include arc welding and electric boilers, industrial motors, lasers, and photocopying machines, okay, and mills and X-rays. These all are the reasons, causes of flicker. Okay. Next, this is the concept of transients. Okay, transients means in syllabus. First topic is the transient and steady state variance. Okay, in transients concept, the concept of transient have this here two. One is the impulse transient. Second one is oscillatory transient. In impulse transient, a sudden non-power frequency changes in the steady state condition. Okay, a sudden non-frequency change in the steady state condition of voltage or current that is direction polarity. Here in the sine wave, here the frequency is the magnitude of the voltage is suddenly increasing unidirection. This is called impulse transient. Here this is the oscillatory transient. In oscillatory transient, the voltage waveform suddenly increasing, both directions positive and negative. Bidirectional polarity, a sudden non-frequency change in the steady state condition of the voltage or current, that is bidirectional polarity, that is called oscillatory transient. Okay, this is total related to power quality problems. Okay. In my next class, I will explain for fax devices. Okay, fax means shunt compensation, series compensation, shunt and series compensation. Okay, thank you for watching this video.